Right, our focus for today is first the OSPF, IPv6, OSPF. Second is ISIS and BGP. Now let's do OSPF first. The IP addresses are already configured. I can see that. This is the IP address on the Ethernet 00 link, and this is the IP address on the loopback interface. And we don't see. Okay, there is also one more IP address on the same interface. This is to teach you that multiple addresses can be active on an interface at the same time. All will be primary, all will be active. If you want to remove that, giving another IP address will not override. You have to cancel it. So show RAN interface, so show RAN interface Ethernet 00. I'm going to cancel the second IP address, which may cause a confusion later. I do not want to have this. Remove this. I also configured the same thing on R2. I would like to remove show run. Now, and then I remove. I do not want to know. This is too making things more complicated. No, not. Okay, so there is no routing protocol now. Show IPv6 protocol. There is no. Oh, here there is a routing protocol. I want to remove this EIGRP 100. So how do we do that? It's very simple. You need to type no IPv6 unicast routing to remove all the routing protocol whatsoever and put back. Okay. Next is I'll go to router 3. Show IPv6 protocol. Again here, no IPv6 unicast routing. IPv6 unicast routing done. Okay, now show IPv6 route. No routes. IPv6 unicast routing. Okay. So this is through the neighbor discovery ND. Okay, so it was learned through neighbor discovery prefix. You remember we configured auto configure on this interface. That is why it shows NDP. NDP means neighbor discovery prefix. Yeah. The prefix is learned from the neighbor. Okay. Now routing protocol OSPF is like this. Are you ready? Very easy, straightforward. Go to the interface. But make sure you have an IPv4 address. Show IP interface brief. Do we have any interface? No, let me put, see, if you do not want to give router ID manually, then you need a IPv4 address in any of the interface. So I'm going to say so that this can be taken as the router ID. Now going to the, where are we? Going to the global mode. No need of going to global mode, I tell you. Just go straight to the interface. Loopback and say IPv6 OSPF process ID area edit. Very simple. You know this. We used to do this in IPv4. Yeah. All right. Now, if you verify show IPv6 interface OSPF interface brief, you can see these two interfaces are running OSPF. Let's check the protocol command. Show IP protocol. You will see a router ID. Actually, it uses a router ID. Show IPv6 protocol. You can see the router ID is automatically picked from the physical loopback interface. Now I'm on R2 interface range loopback. I think so. I remember will give. Now you will see a neighbor coming up. Look at this. Neighbor uses router ID. See, actually, for negotiation, they are not using this address. For negotiation, what address they will be using? Which address? In interface, there are two type of address. Which address? Exactly. The link local address. Where can you show me that? Two places. Show IPv6 route command. In the routing table, you will see the address through which the OSPF has negotiated and learned is a link local address of the neighbor. See, it is not showing the next hop address as the global unicast address. From this, you understand that they are negotiating, they are learning, they are talking using what? Link local address. It says, I learned from this address. If you see, this address is the address of E00 of router 3. Let me show you. Show IPv6 interface brief. If you see here, the link local address is the Ethernet interface address of, isn't it? So they don't use the global unicast address to do all the machine level conversations. They use only the link local. As a result, you no need to you no need to have any policy. Say, for example, you are blocking traffic using global unicast address. The management traffic will be still up and running. You don't need to permit the management traffic. Because the management traffics, they don't use your global unicast, they use link local. So when you block global unicast address, you don't need to unblock for the management, because managements are not going to use the management protocols are not going to use the global unicast address. They use only the link local address. So it's very easy. You don't need to worry about the management protocol. You just focus on the user traffic. When you write policy, you need to only focus on the user traffic. Okay, now we have enabled OSPF, and through OSPF we have learned this route from router 3, isn't it? Is it not OSPF? It is OSPF. Now, as you were saying, you are right. You can also prove this uh, about the link local address by going under the interface. Let's check the interface. Show IP OSPF, show IP v6 OSPF interface Ethernet 0/1. I want to know what interface, what address does interface OSPF interface use to negotiate. Look at this. Yeah, they use the link local address. Right, this is the source address from router 2. This is the destination. This is the address from the router 3. So there is a DRBDR, DRBDR link local address. All right. Do you want me to do it on OSPF on router 1? Not really, not necessary. Let us go and do ISIS. So what is my plan, My plan is this one is OSPF. This one is going to be ISIS. Is it a good idea? Yeah, and then we'll redistribute. So ISIS, I'll say 10. And this is OSPF. All right. Now, let's see how to enable ISIS on router 1. It's like this. We need to give the net ID. So, router, ISIS. You see, IPv6 router, do you have ISIS here? No. So, router, ISIS, give any process ID. I'm going to say 100. 100 or what? 10, 10, 10, and hit enter. And then address family. You got it? IPv6. Unicast. And here, no, sorry. The address family IPv6 is enabled, so don't worry. This command, but it is important. Okay, this command is necessary. The process is enabled. Now we need to say net ID. Net ID 49, area ID, and then system ID and 0. What am I doing? 0, 0. Okay, so next is go to the interface. Interface range loopback 0, comma Ethernet 00, IPv6 router ISIS 10. No, yes, that is all. Show IPv6 ISIS. Is there any command? No. Show CLNS interface. Okay, it is there, but I want another command. Show ISIS IPv6 IPv6. Reboot process, routing information. Okay, anyway, process 10 IPv6 is running. Okay, it's running, but I was trying to show you the interface in a nice way. But here, you see this is showing that loopback is running IPv6 ISIS, and also Ethernet is also running IPv6 process. It's very important, IPv6 process. Huh? Okay, now I want to run only on this interface Ethernet 00. On R2, I'll remove OSPF. Show run interface Ethernet 00. I'll remove OSPF and I put IPv6. Oh, sorry, I put ISIS. Now, router ISIS process ID is locally significant. You can give different number, nothing wrong. I'm just maintaining the consistency. Address family IPv6 unicast, and then net 49. And only one interface Ethernet 00. IPv6 router ISIS. We can expect now neighborship. Show ISIS neighbor. You can see it. It's up. Now I want to know whether I'm learning route from via ISIS show IPv6 router ISIS. I do see now the route, isn't it? You see, it's L1. It's L1. It's I1. L1. ISIS 1. ISIS can have L1 or L2, isn't it? Now we have I1 means what? L1. Within the same area. I2 is inter area. Is it? Correct. Even ISIS is also using what? All protocols will use only a link local to negotiate. Okay. What is next? Next is if I want to ping from R1's Lubeck to R3's Lubeck, I need redistribution, isn't it? Yeah. If I go here and check show IP, show ISI, show IPv6 route, ISIS, I don't see any route because there is no route learned through ISIS. And if I type show IPv6 route, I don't see any route from the OSPF domain. Let's do the redistribution. I'm going to address family redistribute. You understand? It should be under the address family. Yeah. Redistribute OSPF process ID 1 and include connected. And is it L1 route or are we going to send it as L1 route or L2 route? It is up to you. I simply hit enter. Let me see what it does. Now I'll go to router 1 and check. Okay, we have learned it as L2 by default. Okay, these are coming from other, but the administrative distance is same. Okay, all right. Now we need to do the other way, otherwise R3 will not know the reverse path, isn't it? Show IP route. There is no route to reach R1's network. So go to router 2 again. This time go to router IPv6 router OSPF1, redistribute ISIS 10, metric, some metric you can give if you want. I'm giving 50. ISIS routes are L1 routes. Nothing wrong in saying L1, L2. Do both. Include connected. Done. As a result, R3 should be knowing now the routes. Yeah, you see E2, LSA, show IPv6 OSPF database. If you see this, it is LSA type 8. Why? Because it's ISIS. Sorry, it is IPv6. IPv6. Instead of type 5, you will see type 8 here. Type 8. Now, this is the ABR. 2.2.2.2 is the ABR. Intra area prefixes. Intra means within the same area. Prefixes. This is the DR. This is the router. Let's say type 1. Okay, now we should be able to ping 1111::1111 source loopback 0. You can ping now. I want to see in the database, we don't see any IPv6 prefix. Do we see any IPv6 prefix here? No. You see only the router IDs. What did you say? Okay. Okay. You are talking about this one, right? Yes. Yeah. Okay. So let's move on to BGP. Because I have reachability now, between the loopbacks, I can form IBGP between R1 and R3. IPv6 IBGP. IBGP needs reachability because it uses TCP. We all know that. Do we have reachability? Yes, we do have. I can ping the loopback on R3. So if I ping with my loopback to loopback, then I can very well do the three-way handshake followed by BGP negotiation. So let's start the configuration of BGP now. Router BGP. Let's say I would like to have 1000 as the autonomous system number. 1000. So same like ISIS. The BGP configuration is also under the address family. You know the address family, it's MPBGP. BGP is multi-protocol. So one of the protocol among the multiple protocols that BGP supports is IPv6. So I'm going to say neighbor, this address, remote is 1000, neighbor, this address, update source, loopback 0. After this, I have to go under the address family IPv6 unicast and activate that neighbor. So you're not configuring neighbor under this address family. You configure it outside the address family, same like you used to do in IPv4, but you have to go under the address family of IPv6 and activate this. Without this, this is not possible. Now, let's go to the other end. Before that, show IPv6 BGP. There is no command. Okay, so type this command: show BGP IPv6 unicast all unicast summary. Yeah, you see, the neighbor is configured, but it has never come up. The state is idle. The reason is the other side is not configured. Let us go and say router BGP 1000. Neighbor is 11111. Remote AS is this. Neighbor is this. Update source loopback 0. Address family IPv6 unicast. And the neighbor is this. Activate. Now I'm expecting neighborship using the router ID. They negotiate, but They still use the neighbor address to show you. If you check, show BGP IPv6 unicast summary, you can see the neighbors come up, and if you say neighbors, you can see it is using the router ID automatically picked up from the interface. Let me go and check R1, show BGP IPv6 unicast neighbor. Here the address, the neighbor address is 333, which is router 3 is Lubeck. In router 1, show IP interface brief, this is the biggest address and there is no Lubeck interface address with IPv4 address. That's why this is shown as the router ID on R3. Yeah. Correct? All right, now let's advertise a network. On R3, I'm going to create a new interface, Lubeck 33. IPv6 is 33::33/128. IPv6 address. Yeah. This I'm going to advertise under BGP. Router BGP 1000. Advertisement should be done under the address family. Okay. Address family IPv6 unicast network. Just copy and paste this. Okay. Now, let us go and verify whether it is getting advertised first. Just type enter. You see, this network is advertised. Now go to router 1. This is learning it, yeah, from this neighbor. So I should be seeing this thing in routing. We are learning. Now, if you allow to ping this, you can do so. It's you know why it's not pinging? Because router 2 don't know the route. Yeah, we don't have any tunnel between R1 and R3. There is no BGP on router 2. That is why. But it is there in the routing table. In router 2, we don't have. That's why it is not pinging. Right? You need a GRE tunnel, or you need an MPPGP tunnel, or you need something to go directly to router 3. Only then this ping is possible. So we have covered all protocols in IPv6. Do you want me to show anything in the routing protocol with IPv6? You see, if you know IPv4 very well, all those things that you try in IPv4, you can try in IPv6. I have shown you the most of the thing. Yeah, most of the thing where the changes, the differences are, I have shown you already. All the other things are not same, so not different. It is similar, like writing an access list, or changing the administrative distance, or metrics. All the stuff are same. Wherever the changes are, see, the changes are there in the configuration side. I've shown you those things, how to configure EIGRP and IPv6, all those things. So